Yeah, a very good afternoon, ma'am. Ma'am, you are muted. You are muted, ma'am.
Yes. Good afternoon,
Yeah, good.
Dr. Rohit.
Good. How are you,
Uh,
ma'am?
Yes. Pardon?
How are you? How are you?
Oh, okay. I am fine and
Oh,
enjoying
great.
chilling winter here.
Oh,
So
yes.
the temperature is low here at
Yes,
Patna,
yes.
around
Yes,
6 to 7
absolutely.
degrees centigrade.
Okay, great, great, great. Right. Yes. So participants will join lecture. So we will wait for another 2 or 3 minutes,
Yes,
and then we
sure.
will start the session. Right?
Okay, sure,
Yeah.
sure.
Sure, ma'am. Sure. Yeah. So should we start, ma'am? Now we can start the session.
Yes, we can start.
Yeah. Sure.
Am I
So
am I
okay.
audible clearly?
Yes. Yes, ma'am. You are audible. You are audible.
Okay.
Yeah.
Okay.
So, okay, so participants, good afternoon, everyone. So let's welcome our guest of the session, Dr. Seemanti Saha. So let me introduce Dr. Seemanti. Dr. Seemanti is assistant professor at National Institute of Technology, Patna. She has pursued her bachelor's from Kalyani University in 2002, her master's and PhD from IIT Kharagpur in 2006 and 2014, respectively. He, she is a member of different societies, including IEEE, INRASS, URSI, etc. Her research interests includes physical layer of digital and wireless communication, spectrum sensing and sharing in cognitive radio networks, estimation detection theory, neuro-fuzzy based system identification, channel estimation and equalization, evolutionary optimization techniques, including PSO, GA, ANT, colony, D, and their application in communication signal processing, deep fuzzy network. So this was a brief introduction about Dr. Seemanti. Now I will request her to start the session, and I hope that we all are going to be delighted to listen first. So please, over to you, Dr. Seemanti.
Okay, thank you, Dr. Rohit.
Thank you.
So it's a good opportunity for me to interact with you and the audience. Audience comprises mostly PhD students, isn't it?
No, so a few faculties are there and some PhD students.
Okay,
Yeah,
okay.
yeah.
So good afternoon, everybody who are present here. My field of research is wireless communication broadly. Nowadays, I am working on machine learning applications in wireless communication. So when Dr. Rohit has contacted me, I was thinking of giving giving the talk on that topic only. But then he requested that if I can give some take some topic from the area of signal processing. So as communication and signal processing are closely related, basically communication engineering is communication signal processing only. So I have thought that I will choose some other topic from the domain of signal processing, but which is a very what I can say, that is important topic nowadays in modern situation. And one of my research student also is working in this topic. So I am presently exploring the field. So I am also new in this field on which I am going to give you the talk. But so if there is something that you want to point it out, I am wrong in somewhere, then always feel free to interact. And I will be happy if it could be a interactive session. So whenever you feel like discussing, you please stop me and ask questions. I will try to reply it back. And uh, so let's start our discussion or talk. PPT is visible to you?
Yes, ma'am, it's visible.
Okay. So today's talk, the topic is human activity recognition systems based on sensor data using machine learning. So I have seen the topics which has been covered till date. So it's a bit different from that. So I will try to give you a different flavor to you. Uh, so so that it could be an entertaining session. The PPT is visible to you, right?
Yes, ma'am,
Yes,
it's
ma'am.
visible.
Okay. Okay. So in this talk, so I have shared the slide share mode. I have presented in slide share mode. Is it okay? The full screen is visible to you?
No, no, only partial screen is visible.
In that case, you have to log out and log in again. And if I exit the full screen, then is it
It's
visible?
already your screen is being freezed over first slide.
No, first slide I have not moved.
Okay.
Oh, let's see. Now I'm moving my slides. Is it moving?
No, no, there is no change.
No change?
Yeah.
No change?
No change, ma'am.
Okay. Now the slide is changing or not?
No, ma'am, it's freezed.
Reached.
Now your cursor is visible to us. Cursor over the first slide, it's visible to us. From here only, you can we
Okay,
can see
okay.
your
So
screen.
no, okay. So if I change it, now it's changing or not? Just see.
No, ma'am. Yes, now it's changing.
Changing, no? Okay.
Yeah.
So in this mode only, I will present.
Yes.
Okay. So there are few terms in this title, that is human activity recognition, that is HAR, based on sensor data using machine learning. And this sensor data, of course, in a IoT enabled network. That is the sensors which are embedded in an IoT enabled network. So all of us, we know that this is the era of IoT. This is the era of big data and machine learning based techniques. So technology is available with us so that we can use the IoT network to gather huge amount of data, and by processing or gathering those data, we can use the machine learning based techniques to do the human activity recognition. Now first we have to see what is human activity recognition and why it is useful. Basically, uh, uh, I have organized my talk in this way, that is introduction, classification of HAR according to sensor deployment, challenges of HAR in IOHT, that is Internet of Healthcare Network, activity recognition method, a machine learning based approach, state of the art machine learning and deep learning based techniques, future direction of research. First, so as the sensor data is concerned, I am again telling that we are considering the IoT network, and the sensors embedded in the IoT devices will gather data in various situations, and those data will be used to detect various human actions. Now, why the human activity recognition is required? Because the life in our society now, the expectancy has been increased. So we are moving towards an aging society, and this aging society, the gradual degradation in physical and cognitive health could result in fall injuries, cardiovascular, neurological, psychological problems, or a sedentary lifestyle. That is also an curse in our modern lifestyle. So, sensor based human activity recognition is found to be a potential assistive technology in this context to improve the quality of life of an aging society. So, here comes the relevance of this topic. So, in this talk, I will emphasize the Internet of Things or IoT enabled sensor data based human activity recognition systems, where machine learning or deep learning is used to classify human actions in the context of healthcare applications. So, in particular, the impact of IoT on the healthcare industry is so immense that nowadays a new terminology or a dedicated specialization has come out, and the name is Internet of Healthcare Things. Sometimes it is called as Internet of Medical Things, sometimes it is called as Healthcare Internet of Things. So, the same term is coined in different way. So, smart healthcare systems are equipped with different categories of sensors, both wearable, wireless, and ambient sensors. And these amount of huge amount of gathered sensor data, which is a big data, of course, acquired by the IoHT sensors, allows to perform as accurate HAR. That is, whether there is some fall event, whether there is some cardiovascular problem, or some aged person is not moving for a long time. So those are the various human actions which we are going to detect by means of the machine learning, by applying the machine learning algorithm on the gathered sensor data. Uh, the HAR involves detection or classification problems at the end. That is fall detection, seizure detection, etc. Where ML is used, ML is machine learning, of course, extensively. And a lot of MLDL techniques are being used in HAR, including support vector machine, artificial neural network, recurrent neural network, convolutional neural network, deep neural network, short-term memory, long short-term memory neural network, etc. So, uh, and there are immense scope of research in this field nowadays. So we had already seen with the advent of 5G technologies, there was a boom in IoT in the IoT enabling systems. That is IoT enabled smart home, IoT enabled smart healthcare, smart cities, smart traffic management system, etc. However, and we had also seen that we have got an IoT systems in different ways of life with high throughput, low latency, and energy efficient service provision. However, with the unprecedented proliferation of smart devices, nowadays we are keep on adding the smart devices in our daily lives, in all the facets of our daily lives. So there is huge proliferation of the smart devices, and that rapid extension of IoT networks, 5G cannot completely meet the rising technical criteria like autonomous, ultra large scale, highly dynamic, and fully intelligent services. So the fast growth of automated and intelligent IoT networks, it is likely to exceed the capability of 5G wireless systems. So we are gradually moving towards the 6G wireless networks with its accompanying technological trends, and that has recently received much attention both in academia and in industry. And we can see that the technological support of 6G also provide uh, uh, also is going to provide a good support to the IoT systems due to its superior infrastructure over the previous network generations up to 5G, such as ultra low latency communications, extremely high throughput, satellite based customer services, massive and autonomous networks, etc. So the 6G wireless communication networks are envisioned to revolutionize customer services and applications via Internet of Things towards a fully intelligent and autonomous systems. Now, according to IEEE, this is the definition which is given by IEEE. That is, an IoT is a network of items, each of which is enabled with sensors, and these sensors are connected to the internet. So what we do, the sensors gather information, Those information are first processed in the fog or in edge, and after that the processed information will go to the cloud, and we can manage the various systems, IoT enabled systems. So we can see this is a good diagram which can which shows that in 2020s we are having ultra high density videos, smart IoT devices, and we are getting 1 to 10 gbps of throughput and less than 1 millisecond of latency with the advent of 5G technologies. Now, 6G technology, which is upcoming technology, and this is going to give a big support to the next generation IoT systems and IoT applications. And this is going to be a very high speed communication systems, which is aiming to be to reach 1 terabytes per second data rate. And all the mentioned features of IoT, like full coverage, massive IoT, mobile apps using artificial intelligence, satellite communications, autonomous system, those are the few features of the sixth generation wireless communication systems. And the sixth generation IoT application includes first and the foremost is Internet of Healthcare Things, that is IOHT, the topic on which I am going to deliver this talk today. That is, 6G IoT comprises these areas: Internet of Healthcare Things, vehicular Internet of Things and autonomous driving, unmanned aerial vehicles, satellite Internet of Things, industrial Internet of Things. So, first and foremost is the Internet of Healthcare Things, which is very much required not only for the aging society but also for to enable the smart healthcare systems in a hospital or in a healthcare providing in the healthcare providing business. So it is going to be a uh, this is going to be a part of it. And in this IOHT, this is another diagram you can see, that is all the all the devices are connected to the 6G core network. We are seeing that there are satellites, UAV terrestrial communications, UAV devices are connected, mobile broadcasts is also there, industrial Internet of Things is there, mobile IoT users are there, and Internet of Healthcare Things. With an Internet of Healthcare Things, you can see in the figure there is hospital, smart wearables like smart watches, and mobile phones, AI enabled healthcare apps in the mobile phones, implanted devices, that is the devices, suppose pacemaker, that will be also enabled with AI, and that also will be AI enabled. The robotic surgery with the help of robotic hands could be possible. So these are all the parts of an Internet of Healthcare Things. And today I will focus my lecture on the human activity recognition in a IOHT enabled system. That is how the human activity recognition, that is human activity, I have already told, that is scissor detection, fall detection, etc. That will be how that will be possible with the help of using the machine learning based technique on the gathered data which is gathered by the IOHT devices. I hope the slides are visible to all of you.
Yes, ma'am. Slides are visible.
Okay. So if I do the slide, I go to slideshow mode. Now you please see that whether it is moving or not. Is it moving?
No, ma'am.
No, na?
No.
Okay. Now it's moving.
Yes, ma'am.
Okay. So this is a representative diagram of an IoHT system. So IoT, that is playing a pivotal role in the healthcare industry, and we had seen that with the help of IoT technologies, the hospitals, the wearables, the apps in our mobile phones, and the along and the implantable, the devices which is implanted in human body, all are connected through some IoHT network. And in IoHT network, first you see these are the sensors and wearable. Some sensors are installed in the ambience, that is in the surroundings. Some sensors are wearable. Like there are cardiac monitoring, there are wearable sensors, and some sensors are there in the surroundings also. So these sensors are collected. The sensors means these sensors are embedded in the IoT devices. Rather, we can use the term in IoHT devices. So those sensors will gather various amount of health data, and these health data will be transmitted through Wi-Fi, Bluetooth, Zigbee to the edge or fog node. So there will be some kind of data processing here. After these data processed data, that will be some kind of data processing could be done in the cloud layer. Some processing will be, in the fog layer, and the some processing will be done in the cloud layer also. So from the fog or edge node, the processed data will be transmitted to the data center through various 4G, 5G technologies, LoRa, NB-IoT technologies, and in the data center, that is in the cloud, that will process the data. And in this data processing and the classification, in the part of data processing and the classification, machine learning and deep learning is playing a big role. So our topic of discussion today is that how we will identify or detect some human action on sensor gathered data by using machine learning or deep learning based techniques. So I hope what the topic today's topic is clear to everybody. Then I will proceed to the next slide. So categories of IoT sensors in smart healthcare systems. First is wearable sensors, which are classically used in wireless body area networks. Ambient sensors like surveillance cameras, passive infrared sensors, etc. Smartphones, smartwatches, smart clothes, etc. Along with that, Wi-Fi hub, RFID sensors, frequency modulated continuous wave radar, etc. So these are the IoT sensors which are going to be used in smart healthcare systems. And the huge amount of sensor data gathered by different IoHT devices allows us to perform accurate human activity recognition. So two things basically we need. First off, deployment of the sensors, accurate sensors, and the amount of data which we want to gather. If as much as data we can gather, that will be good for us. Just a minute. Okay, sorry. So the huge amount of data gathered by the sensors, which are enabled in the IoHT devices, allow us to perform accurate human activity recognition. Now, these are the various kind of HAR which we are going to do, which are going to perform in a smart healthcare system. First is fall and seizure detection, long-term monitoring of the patient, psychological healthcare applications, detection and prevention of numerous chronic diseases, recognizing the abnormalities in regular lifestyle. So these are the areas where HAR is going to play a very important and crucial role. So human activity recognition from sensing data. The basic enabling technologies include the enabling ML and DL algorithms that perform HAR. So first, you see the accelerometer, gyroscope, heart rate, etc. These are the data acquisition and data in our mobile phone. Also, the gyroscope is there, and in some phones, heart rate monitoring is possible. So that this data will be gathered here, and this is the raw data. Now, this from this raw data, there will be two types of feature extraction will be there. Few are the handcrafted features, that is, we can do it mathematically or we can extract it mathematically on our own. So first, what we do, this is the raw data. The raw data is processed, that is, denoising of data is done. After that, two kinds of features are being extracted. First is automatic extraction of features through deep networks like CNN, and second one is the conventional extraction of features, which is done in conventional machine learning algorithms. That is first preprocessing of data, then segmentation of data, then extraction of features. And these we call handcrafted features. And and in deep learning network, the features are automatically detected or automatically extracted through the deep networks. So this is the difference between the automatic feature extraction through deep network and the handcrafted feature extraction. Now, there are these handcrafted features in conventional machine learning algorithm. We use artificial neural network, MLP, support vector machine, random forest algorithm, naive Bayes algorithm, etc. for classifying these handcrafted features. And in deep network, the CNN, RNN, DBN, they are used to classify for classification. Now, when the classification is done, that means now we can identify that what kind of human action has taken place. So this classification through these networks will enable us to identify or detect various human actions, and that we call human activity recognition. So these are the steps for human activity recognition from sensor data. First is the sensing step. Sensing step, we gathered or acquired the data. That is the raw data. Denoising is done in the raw data. Now, in either we extract the features automatically through deep network, or the shallow features can be extracted by in conventional machine learning algorithm. Then conventional classifiers and the deep learning classifiers, they are used to identify or detect various human actions. So this is in brief, or this is a sketchy diagram for human activity recognition by means of MLDL technologies. Now, classification of HAR according to sensor deployment. So HAR based on ambient sensor, we call it ambient sensor based HAR. HAR based on variable sensor, we call it variable sensor based HAR. HAR based on hybrid sensor, we call it hybrid sensor based HAR. Among that, the variable sensor based HAR is more attractive solution due to its flexibility in daily use, low cost, and acceptable performance. Almost all of us, we used to wear nowadays some smartwatch or a Fitbit kind of thing for health monitoring. That is how much, how many steps we have walked today, how many, what is my heart rate, etc. Everything could be trackable by those devices. So hence WSHR is found extensive use in assisted living, such as rehabilitation, gait analysis, fall detection, sports assessment, daily activity analysis, etc. Ambient sensor-based HAR recognize human activities from the data acquired from ambient sensors, so that are installed in the surroundings like door, wall, floor, kettle, furniture, etc. That is, suppose a temperature sensor. They could be embedded in the surroundings. So the ambient sensors include a reed switch sensor, light sensor, passive infrared sensor, radio frequency identification, pressure sensor, flow sensor, temperature sensor, etc. And of course, cameras. So the cameras are also could be used as a IOST device. ASHAR sensor is less intrusive because इसमें intrusion नहीं होता है body में, and there is no on-body deployment, but it is less flexible and demands more complex sensor placement at home. But sometimes we do not want to wear. Wearable is not welcome, especially for the elderly people. They do not want to wear much things. This seems to be clumsy for them. So they do not want to wear those wearable sensors. So for them, these ambient sensor-based systems are really useful. So further, ASHAR operates in restricted area in which the sensors are installed. Further, ambient sensors becomes non-functional when the consumer does not communicate with the objects containing those sensors or does not move in the operational area of the ambient sensor. That if I am not going in the operational area where is the sensor is installed, then there is no use of installing those ambient sensors. But it's not possible also. Suppose we want to install sensor uh, around all the rooms of my home. So that is will be a very costly solution. So for a bedridden patient, the wearable sensor may be a solution. The ambient sensor may be a solution. Otherwise, wearable is a better solution. So WS sensor, that is a wearable sensor. So functioning area, we can carry it. So it is mobile in nature. So that is the best thing about WS-HAR. And the performance and the robustness of WS-HAR are enhanced by placing more sensors and different body parts like wrists, feet, head, legs, weights, etc. However, the problem is that is more sensor on the body results in higher cost, difficulties in deployment, and intrusions for aging people with an independent lifestyle, because they want independent lifestyle. They do not want those kind of intrusion in their life. So for them, it's not a very good solution, though we are in near future, we are going to use those kind of solutions. And another is HS-HAR, that is, it is having that is we have call it, that is hybrid sensor. So hybrid sensor is that ASHAR and WSHAR both have their own merits and demerits. It is evident that recognition accuracy could be enhanced by combining different sensor modalities. So HSHAR would increase both the complexity and the activity or heart rate and heart rate variability. So typically used smartphone sensors are image sensor, that is camera, and microphone. Next, monitored health issues is eye health, image sensor, camera. Respiratory and lung health, image sensor, camera, and microphone. Skin health, image sensor, camera. Daily activity and fall, motion sensors, that is accelerometer, gyroscope, proximity sensors, global positioning systems. Sleep, motion sensors, that is accelerometer and gyroscope. Ear health, microphone. Cognitive function and mental health, for that, motion sensors like accelerometer and gyroscope, camera, light sensors, and GPS. So these facilities are there in our um in our mobile phones, and with using those sensors we can develop some applications by which we can get the various health data. Nowadays I have come across one sensor for SpO2 measurement also, that is oxygen saturation measurement, that is also have been done by using the torch which is there in our smartphones. So general components of a heart system. First is selection and deployment of appropriate sensors, either on the human body or in the ambience. Then data acquisition. So for data acquisition, we need to have data acquisition devices like cell phone, laptops, etc. Then there is data communication and data pre-processing gathered data at edge, fog, and cloud. So first, the raw data, which is gathered by various sensing IoHT devices, they are communicated through TCP/IP or UDP protocol to the local Wi-Fi router or to the nearby cellular network. So there is some kind of processing of the data. Then the half-cooked data, we can say the half-cooked data, that will be, so some cooking is done here, some data processing is done here in this fog. After that half-cooked data is transferred through the to the main data center or in cloud. So here the inference is taken place. That is what some kind of classification could take place here, and some kind of classification if it needs data from multiple sensors over a long time, then the decision would be taken in the cloud server. So it depends what kind of human actions you are going to predict, and some kind of human actions could be identified by doing the data processing and classification in the fog or edge itself. So fog or edge processing and the cloud processing, both are very much important in case of HAR. So this is one example of wireless sensing. So for wireless sensing, these are the various measurements we are taking. One is RSSI, one is CSI, FMCW radar, and Doppler shift. So what are the metric which we are deriving from there? For RSSI is the signal strength, CSI is the channel condition variations, FMCW radar frequency shift associated with human body depth, and Doppler shift frequency shift associated with human body moving speed. So this is the data which could be gathered by wireless sensing. After that, signal is pre-processed. Then from the pre-processed signal, feature is extracted. From the extracted feature, we apply the machine learning based algorithms or deep learning based algorithms for to detect or to identify or to recognize various human actions. And those identified actions are intrusion detection, room occupancy monitoring, daily activity recognition, gesture recognition, vital signs recognition, user identification, indoor localization, and tracking. So these are the all applications. Among that, few will be for healthcare applications, like vital sign monitoring. Here it is vital sign monitoring. So, few challenges of HAR in IOHT with their solution. So, there are some tools are there like for indexing, like activities of daily living index have been developed in elderly care, and experimental challenges accompanying data acquisition and validation of HAR systems under realistic conditions. So, huge amount of research is going on battery life also. That is on a battery to reduce the cost, weight, size, form factor, etc. Because data acquisition process that need wide ranging requirement, that is high data quality, long term recording, large number of sensors, etc. So hardware that is when we are going to deploy the sensors, we need to think about the accompanying cost with it, because under realistic condition these data acquisition could be or could take place for a long time, so we need a long battery life as well. So on the for these devices or for these applications, the research is going on the battery to reduce the cost, weight, size and form factor, and to increase the charge storage capacity or the battery life. And also, the research is going on for designing low power, low cost, high sampling rate ADC for enabling HAR in for IoHT applications. Another point to be observed is that some health monitoring sensors are classically intrusive in nature, and it creates a true hazard in IoHT, especially in the context of daily living. So there is presently low-cost, non-invasive sensors are there for blood pressure and heart rate measurement, hemoglobin measurement, plasma glucose measurement. So that is non-intrusive in nature. Blood oxygen level monitoring, because in this time, in this pandemic era, we already have seen the SpO2 monitor, which is non-intrusive in nature. So we always try to develop or deploy the sensors which are non-intrusive in nature. Furthermore, hard system design and implementation face tough challenges regarding a trade-off between system latency, processing power, and accuracy. So 5G communication reduces the latency to less than 1 millisecond. The required processing power has been achieved through onset of fog edge cloud computing. And I have already discussed that with the advent of 6G wireless networks and their accompanying technological trends, this is going to enable IoHT actually or possible in a realistic scenario. Now we will come to the next portion of our discussion, that is activity recognition method through a machine learning based approach. So, first is that why we should use ML in HAR. So already we have discussed that the human activity recognition, that is specific, that is a classification problem at the end. So for that, we need to have labeled data so that there will be no ambiguity in detection, because it is related to human healthcare and with the elderly care and the assisted living. So as it is, and in the with the advent of 6G communication systems, we are going to have the robotic hand surgery as well. So there also we need a very good amount of precision So for that, classification of different human activities is a really involved problem, in the sense that the human activities are ambiguous themselves, and are often the data associated with it are weakly labeled. Furthermore, the effect of such human activities on different sensor data is not always logically interpretable. That is, two major point is there. That is, one is weakly labeled data, and another is the lack of interpretability in the gathered data. So, so by analyzing those data manually or by some conventional technique, always it is not possible to to come to some correct decision, which is very much required, because we need to have a correct recognition of human action. So if the data is not interpretable and it is ambiguous data, it's not weak, it is weakly labeled data. So in that case, the manual classification or recognition, as well as recognition or classification by some conventional technique, will not be very much useful. So that's why we are going to use the machine learning based techniques in this context, so that we can train our machine through some data and it will act accordingly later on. So in a sensitive task like HAR, where misdetection and false alarm could be heavily consequential. So I hope that you know these two terms, that is misdetection and false alarm. With the classification theory, these two terms always comes. Suppose there is some fall of an elderly person. So there will be fall of the elderly person, or there will be no fall. So there is two situations. That is, the elderly person is falling, or he or she is not falling. So we have to detect that whether he is falling or not. Suppose now, if the person is about to fall, but our machine is not able to detect that the person is falling, so it will not ring some alarm, or it will not inform the healthcare provider that the elderly person fell on the ground. So this phenomena is called misdetection. That is, there is a fall situation, but the IOHT system is not able to detect it correctly. So there is misdetection. And another is false alarm. That is, nothing has happened, but the system has detected is something happened to the elderly person, and it has informed his or her healthcare provider by sending some message. That is, some alert message will go to the healthcare provider that something happened to the elderly person. So that is called false alarm. So our target is that the misdetection and false alarm should be minimized. And this misdetection and false alarm means error. So what we want? That we want to minimize this error in our detection. So we had seen, and the researchers had already proven, that on the use of machine learning can minimize this minimize the misdetection and false alarm. Next point is massive growth in the IOHT sector owes to provide a huge amount of training and testing data to solve different types of hard problem in connection to healthcare services. So this is the era of big data. So I think that nowadays, with the huge computational facility which is already available with us, the data gathering, the acquisition of data and storing of data is not a big problem. And another thing is that there is opportunity of using deep learning algorithms utilizing the edge computing facility of modern wireless network architecture, and a huge amount of research work is initiated throughout the globe on machine learning and deep learning based HAR in IOHT for IOHT applications. Now, first, uh, for this classification or ML based approach, first what we have to do, that is data pre-processing. Data processing has to take place because the raw data, that is noisy in nature. Moreover, the raw data is having it's not in a format in which we want that data. Sometimes the data is sometimes data has to be pre-processed to convert it to convert it like a image, like a 2D matrix, for to be used for some kind of transformations. Like, so raw data pre-processing is very important step in any pattern recognition system. So the subsequent steps of pre-processing of hard sensor data are as follows. First is denoising. So because this data is noisy data, of course, so there are several denoising algorithms, like that is moving average filtering, low pass filtering, or by using, that is a very nice and beautiful technique, that discrete wavelet transform, denoising of data by DWT, and it is heavily used for DWT. Next is conversion of time domain signal or data log to image like 2D matrix. Because sometimes this conversion from 1D signal to 2D signal is required to apply the appropriate machine learning technique for the human activity recognition. So the conversion of the time domain data to 2D matrix to facilitate the usage of the plethora of deep learning techniques developed mainly in the connection with image processing. However, always this step is not mandatory. It depends that which kind of machine learning techniques we are going to use. Depending on that, the data will be converted to 2D matrix or not. Next is third step is segmentation. So segmentation using different algorithms as per origin of the signal. We will see that is what is segmentation. And the most important step is feature extraction. That is, we need to extract useful feature from the raw data or the process data so that we can do the identification or classification. And the next is feature selection and the dimensionality reduction. Sometimes the feature which we extract, that is a that is having a large dimension, and some of the features are not very useful. Rather, it may harm the detection process. That is, it may interrupt into the detection process. So the feature selection is needed. Useful features we only select from the extracted features. So it will do two things. One is the dimensionality will be reduced. So the complexity of the algorithm will be reduced. And another thing is that we can remove the harmful features. So the last point, that is the feature selection and dimensionality reduction, that is also very much important in the context of HAR. So these are the example of HAR signal, few typical HAR signal. So this is a triaxial accelerometer signal. This is triaxial gyroscope signal. This is triaxial magnetometer signals. So this is the signal produced by body-owned inertial sensor or magnetometers. Next is CSI, that is channel state information of a radio channel. And that is here the sensor is, or the device which are using, that is Wi-Fi. Wi-Fi node. So CSI of a good channel, the red one is the CSI of a good channel and CSI of a poor channel. You can see there is a dip, the channel is poor, so there is a dip in the CSI of a poor channel. Next is CSI of a radio channel, which could easily be extracted from Wi-Fi node using freely available dedicated tools. This is frequency time Doppler profile obtained from pulse Doppler radar of an example gesture. The user moves her hand towards the receiver. So this is the Doppler frequency time Doppler profile. This is average RSS with different activities over time obtained from wearable RFID tag. So this is RSSI from the wearable RFID tag. This is the sitting position, this is in standing position, and this is in walking position. So these are example of few heart signal, typical heart signal, raw. We have not done any signal processing on it. Okay. So, Dr. Rohit, I want a 2-minute break.
Yes, ma'am. You can take, and participants will explore whatever they have learned.
Yes, just a 2-minute break. Okay,
Yes,
I'll be
ma'am.
back by 2 minutes.
Okay.
Okay, welcome back. Next is So these are all raw signal and the example of raw data. Next is, am I audible to everybody?
Yes, ma'am, you are audible.
Yes, ma'am.
Am I audible?
Yes, ma'am, you are audible.
Okay. Yes. Next is denoising. So for denoising, always we use the low pass filters. So there are basically low pass filters and the moving average filters we use for denoising. So these are the example of noisy CSI, channel state information, and the noise is reduced by using Butterworth, Chebyshev or elliptic filters. And we will get a smooth version of the signal. And best noise removal could be done by using DWT or by PCA, that is principal component analysis processing. You may see in PCA more smooth signal you are getting, and there is amplitude enhancement also by PCA. In the PCA, there is amplitude enhancement also. So not only we are removing the noise, but we can enhance the amplitude as well. So it will be used for better, but for detection, it will be more useful. But another thing is that if there is in PCA, the high frequency components are lost totally. Only the low frequency components exist. So sometimes there will be information loss by PCA analysis. So this is for kicking action. For kicking action, this is the raw CSI, which is captured by Wi-Fi hub. And this is the smoothened signal or denoised signal by Butterworth low pass filtering. So, however, care should be taken, that I was telling, that there should not be any vital information should not be lost during denoising. The vital information should not be lost during denoising. So that care we have to take. These are especially applicable in the case where the age information of the signal is used for detection. So where in the situation where age information is used, there is a chance of losing the data. So we have to take care, that is to do the smoothing or the denoising, we should not lose any vital information, especially where the age information is used for classification. Next is conversion, the second step, that is the conversion of time domain signal or data to data log to image like 2D matrix. Again, I am telling everywhere it is not needed. But sometimes for some machine learning techniques, it is needed to convert the signal to 2D matrix. So in many cases, 1D time domain signal is directly used in ML. Sometimes it has to be converted to 2D matrix. Now, where it is to be converted, like in CNN, where we apply CNN, there we need to convert the data in like a 2D matrix. And generally, a spectrogram is generated using short-time Fourier transform. So we use STFT for this. And the XXXI is the signal to be represented in the time frequency domain, and this is the window function shifted by these points. At present, dedicated block and command is available for spectrogram in NI LabVIEW or in MATLAB. So there are inbuilt routines are there. So easily you can convert the signal from 1D signal to 2D. So this is the spectrogram for inertial sensors during different human activity. So this is input, 3-axis accelerometer and 3-axis gyroscope. And these are the spectrogram. This is during the public transport. In the figure B, the left part is moving in public transport, and the right part is while in standing position. Extracted DWT spectrograms for CSI during 3 typical HAR activity. DWT spectrogram for walking activity, the DWT spectrogram for falling activity, and next is for hand pushing hand activity. So these are the also few techniques by which we can convert the 1D data to 2D spectrogram. Next is segmentation. So segmentation is done to remove the inactive portion of the sensor data. So after denoising and the 1 to D conversion, we do segmentation. And segmentation is done to remove the inactive portion of the sensor data. Furthermore, when different activities are performed one after another, in a practical scenario, segmentation of sensor data is required to isolate one period activity from another. A very standard technique of segmentation is thresholding. Adaptive activity cutting algorithm outperforms the standard thresholding based segmentation algorithm. So this is segmentation. You see the segmentation on CSI data, the pre-processed CSI data for push action. A represents the CSI data for the push action. B is the signal segmented using the C is the signal segmented using the standard thresholding technique. And D is the signal segmented using AACA technique. So these are various segmentation technique which is used in this HAR detection by using machine learning based approaches. Next is feature extraction. A very important part in this, or a very important block we can say, and huge research is going on this part. Actually, everywhere, in every part of it, the research is going on. If you say it is the denoising, the research is going on. In segmentation also, the research is going on, and feature extraction. The research, a huge research, and is a lot of research is being carried out in this part. So after segmenting the sensor data, feature extraction is adopted to extract useful features. This term useful is really important. The useful features. We have to extract useful features after from each time window. हर एक time window से useful feature हमें extract करना है. In general, two approaches have been applied for feature extraction. One is statistical approach, another is structural approach. For statistical approaches, Fourier transform, discrete Fourier transform, discrete cosine transform, short-time Fourier transform, DWT, etc., use quantitative characteristics of the data to extract features. And in structural approaches, consider the interrelationship among the data. That is what is the correlation among the data. That characteristics is used for structural feature extraction. Researchers have used extracted time domain and frequency domain handcrafted features based on domain knowledge. So state-of-the-art research focuses on deep learning approaches in HAR to automatically learn features. That we have told in conventional research, conventional machine learning algorithms, we need to extract features, time domain and frequency domain features based on domain knowledge, and we call it handcrafted features or shallow features. But the state of the research focuses on deep learning approaches in R to automatically learn the feature. And sometimes there is hybrid approaches. That is, we learn the features automatically by deep learning algorithm, and it will be concatenated with the handcrafted features for better recognition or detection performance. The handcrafted features are lightweight. The advantage is that, whereas the strength of the deep features is that it could be automatically learned. So the example of some well-equipped time domain features are mean, median, variance, kurtosis, skewness, zero crossing rate, autoregressive coefficient, peak-to-peak value, etc. Some frequency domain features that are spectral energy, entropy, dominant frequency, etc. And it could be extracted by using FFT, DWT, DCT, etc. Nowadays, the wavelet packet decomposition, the empirical mode decomposition, variable mode decomposition, VMD, they are also used as feature extractors for automated seizure detection and prediction based on EEG measurement. Deep features are extracted using deep networks like CNN, LSTM, RNN, DNN, etc. And these are very useful, very effective, especially in IOHT applications. Now, there are few techniques which are used, that is time warping, which is used to identify the similarity between two time sequences, which are misaligned in phase, is used for feature extraction in R. Pearson correlation, which could easily be evaluated for scattered data without finding out the ensemble mean of the feature vectors, finds extensive use in R system. And combined features, that I have already told, that is combining or concatenating the deep features with the handcrafted features, that are also used in R by using ML techniques. Now, next is presence of unnecessary features. So, presence of unnecessary features increase the computational complexity. First is increase the computational complexity, because if there are unnecessary features, the dimension of the feature space will increase, and that will increase the computational complexity as a result. So, and another is that if there are some misleading feature, that will also degrade, the misleading features will degrade or hamper the classification performance of the ML techniques. So this is one useful point to be noted. Another is the feature extraction and feature selection for detection using CNN, like deep learning networks, are supposed to be done automatically, and this is one of the lucrative feature of CNN. So CNN में क्या होता है? That is, the features are learned and selected. Features are extracted and useful features are selected automatically using CNN network. We need not to think of it. And that makes the CNN very attractive tool for her in a IOHT environment. Next is feature selection and dimensionality reduction. So if we extract features of a large dimension, so the complexity will be high of the algorithm. So what we need to do, we need to select some useful feature, so that as a result, the dimensionality will reduce, the complexity will reduce, as well as some bad features will not hamper the detection performance. So for that, feature selection procedure is adopted, and wrapper-based, filter-based, and correlation-based approaches are performed. Moreover, the principal component analysis, autoencoders, sparse filtering, etc., are also used to reduce the dimensionality of a feature vector. Among those techniques, like in PCA, autoencoder, sparse filtering, PCA is the most popularly used. PCA is most popularly used to reduce the heart signal feature space dimensionality. So what PCA does, it does away, or it removes the undesired components of the signal and thereby pronounces the features to be used during classification. This is accomplished by keeping only few significant eigenvectors in PCA analysis. That is, the eigenvectors with lower eigenvalues will be kept and other will be removed. Now, last step, that is learning or and in the inference. That is, we have to draw the inference. Suppose there is a seizure detection. So there is a seizure of the patient or not. So we have to draw the inference in her. So after the feature extraction phase, classification is performed to identify or recognize the human activity for which we intend to. Classifiers interpret the extracted input features and predict the activity, that is fault detection and seizure detection, etc. So in connection to her, the classification problem could be broadly categorized into two types. That is classification of linearly separable classes. This is given in this figure, and non-linearly separable classes, because in this class you cannot separate it by a plane. Okay, so linearly separable classes and non-linearly separable classes. So these are the two types of classification in case of her. Now, this is some scatter plot of some extracted feature using waste location dataset in order to compare the activities of daily living and fall events. So this is the red one is the fall event. This is the fall event. When the fall event takes place, this is the scatter plot for the fall event. And these are the plot of some extracted features. So you can see here in the third figure, where energy related features are extracted, it is linearly separable. Or here in the postural features, it is also linearly separable. But in this feature, statistical feature, it is not range. Where range is plotted, it is not linearly separable. And the reference based, this is also not linearly separable. So there are some linearly separable. When the classes are linearly separable, it is easy to classify than the non-linearly separable classes. Now, classification algorithms can be classified into the following two categories. One is conventional algorithms and deep learning algorithms. Conventional algorithms like radial basis function neural network, hidden Markov model, dynamic Bayesian network, support vector machines, etc. K nearest neighborhood classification, random forest algorithm, etc. Whereas the deep networks includes CNN, RNN, DNN, LSTM, etc. And the beauty of the deep learning network is that it will learn, it will extract and it will extract select features automatically along with the classification in a simultaneous fashion. So that is the beauty with the deep networks. Nowadays, so people are so eager to using the deep learning algorithms, and we are having we are having huge computational complexity, huge computational resources. That's why it is if at all the computational complexity is high, we can manage it, because the computational resources with us are nowadays also huge. Now, there are so many different state of the art ML techniques that I will highlight a few of it to show you that in which problems, how the in HAR, how the problems are being tackled, or the researchers are uh, which kind of ML techniques the researcher is using nowadays for her in a IOHT perspective. So one important thing is that we had already seen that in machine learning technique, there are two type of features. One is the shallow feature or the handcrafted features, and another is the deep features that is automatically learned by the deep learning networks. Now, what in the modern research is showing that augmentation of the so-called shallow features, which are mostly statistical features. I can show you what are the shallow features in this table. So this is the shallow features, that is amplitude, kurtosis, variance, mean, skewness, mean, median, etc. So these are the shallow features, and they are the mostly the statistical features. So there is a trend nowadays that is to concatenate those shallow features, or to augment those shallow features uh, with the deep learning, in the deep learning paradigm, to improve the recognition performance or to improve the performance of a human activity classifier. So human activity classifier means which can classify the human activities. So that is the typical shallow features, that is the statistical features. Nowadays, what people are doing, they are augmenting those shallow features with it in a deep learning framework, so that at the end, the detection performance or the recognition performance will be improved, could be improved. So this is one example in the figure. We can see that this is a spectrogram, and this is the deep learning module. So in the deep learning module, along with the deep learning module, we are concatenating some shallow features, and these shallow features are augmented with the deep learning layer, in the deep learning layer, and the output, by using the softmax function, we are getting the classifier output. So this is, we can say, that is the generic diagram. The next diagram, we will see you the generic diagram for augmenting the schematic diagram of this model, where the handcrafted features with the deep features obtained from CNN is reported. So you see, here is the sensor data. Now sensor data is first, denoising is done. So denoising block is there, though it is not drawn here, but the denoising block is there. Then it is segmentation is there. Then data encoding is there. Then this is an image representation, means want to do deconversion is done here. So deep feature extraction is done in this phase, and the conventional statistical features, handcrafted features, or shallow features are extracted here. So this is the total feature space, that is the deep feature vector and the handcrafted feature vector. Now the feature space is concatenated, or we get the concatenated deep feature. Then we are using the SVM classifier. So classifier which we are using, that is a machine learning based classifier, not a deep learning based classifier. But for the extraction of the feature, we are using a deep learning technique. So CNN is used for that. You see here, multi-layer CNN is used. And CNN is used to extract the deep features. And these deep features are augmented with the handcrafted features. Again, I am telling these handcrafted features is the statistical features or the shallow features. All these we call it in these three names. And in these concatenated features will be given as an input to the SVM classifier, and the action class will be determined or action class will be recognized, and we can recognize the human action. Now, we will the tentative list of neural network structure which is used for it is used in the recent research work, that is DNN, CNN. DNN is feed forward MLP with deep layers. CNN, convolutional neural network, LSTM, gated of recurrent ANN or RNN, that is ANN with feedback, typically used in deep learning. Attention model, that assigns a score value to each feature, allowing the deep network to focus on the important part of the data. So attention mechanism is an important, some new technique which is used along with the several neural deep networks nowadays. So what attention mechanism does, that it assigns a score value to each feature, allowing the deep network to focus on the important part of the data. That is the part of the data which contains more information. Deep belief network, that uses Bayesian statistics. Stacked encoder, a feed-forward neural network that learns through decoding, encoding, and this stacked encoder is extensively used in communication systems nowadays. And hybrid combination of different DL models. So now I will discuss few cases, case studies, which is important. I found important in several literature, and which will give you an idea that is what is going on in this sector nowadays. So this is an hybrid heart technique where both CNN and attention mechanism are used in this case one. And the experiment, sorry. This is a 6 class recognition problem where A1 to A6 are the class levels, and CNN is used along with the attention mechanism. Now, this is another model, a novel deep learning model for HAR called ST Deep HAR has been proposed to utilize both the temporal and spatial data. So this is here both the LSTM and MLP classifiers are used to ensure improved performance. And if you see the relevant paper, you will see that performance is improved a lot. So here what we do, that a novel DL model for HAR that is called ST Deep HAR is used here. In the reference number 54, we will see the detailed mathematics and the block diagram of it. The first channel includes LSTM for efficient sequential feature extraction. So first the LSTM is used for feature extraction, and the after the LSTM block, there is attention mechanism that enhances and fine tunes the temporal features. So it will enhance the useful features, useful temporal features. The second channel that you see, this is the second channel, this one. The second channel is designed using 1D convolutional residual network. It is called ResNet. 1D convolutional residual network called ResNet that effectively extracts spatial features. So the upper channel is used to extract temporal features using LSTM, and this LSTM block is trailed by the attention mechanism to enhance few of the temporal features. And the next is use the ResNet, and this ResNet, that is 1D convolutional residual network that extracts the spatial features. And there is another technique, adaptive squeeze and excite operation. Adaptive AC. There is adaptive squeeze and excite operation that is used to enhance the spatial feature extraction here. Now, these two features, that is here in the upper channel, the temporal features, and in the lower channel, the spatial features, they are concatenated to classify various activities finally. And finally, you see, MLP is used as a classifier with softmax thresholding, and various classes or various activity classes. Activity means human activity classes are recognized. Now, the next example, that is a two-layer HAR framework is proposed in case 3 for classifying different gym physical activities, GPA, gym physical activities. In layer 1, a one-class SVM is applied to coarsely classify the free weight and non-free weight activities. Whereas in the second layer, an ANN is used for recognition of aerobic and sedentary activities. And apart from that, an HMM, hidden Markov model, is incorporated to classify free weight activities. So in the literature, it has been shown that the proposed approach has given the better recognizing performance in measuring the gym physical activities as compared to other existing algorithms. Now, another problem is, another important thing is that I have already told that when the data is weakly labeled, that is the data type is ambiguous, then in that case, the machine learning and deep learning is going to be very useful. Now, one example, in this example, we can show that the HAR in this HAR, it is a weakly labeled sensor data. And to enhance that sensor data, deep Q network based auto labeling mechanism is used. Deep queue network using the auto labeling mechanism is used. So this deep queue mechanism that you can see in reference number 78. So there are many more in the reference list. You may see there are lot many paper is listed, and in which the people are using the machine learning and the deep learning based techniques in recognizing various human actions which is required for IOHT applications. So the future directions of research is that is the with the advent of harvest supportive technologies in IOHT, users' quality of life is continuously being improved, especially for the aging society and also for the physically or mentally challenged. Not only that, for us also, for us who are leading a very bad kind of lifestyle, in the sense that is lack of physical activities, always doing some table job and doing something on computers, to get a track of our health conditions, this HAR is going to be a very useful tool. And for that, machine learning techniques is very much promising for an accurate HAR, and that will enable the IOHT is really possible for future 6G IOHT technology. And we can see the next I will discuss few challenges regarding the accuracy, robustness, cost, and unobtrusiveness of HAR. So first, some open research problem I will like to discuss. That is design and implementation of a HAR system to cater to the need of aged people who are not that much conversant with information technology. If you see that if some person nowadays is above 65 or 70, they cannot operate a mobile phone, or they cannot handle the applications of mobile phone very conveniently, and they that is beyond their comfort zone. So to make this HAR system or the IOHT system user friendly, especially for the elderly people, that is one challenge. In the case of wrist-worn sensors like smartwatches for heart, the sensor data suffer high intra-class variance due to the similar activities done by wrist movement, which in turn decreases the recognition activity due to some easily misclassified like brushing of teeth, eating and feeding. For that, we are having same type of wrist movement. But what we are doing exactly, whether we are brushing our teeth or whether we are eating, that is that cannot be classified. So this for this kind of wrist-tone sensors, this is one open problem. Underutilization of sensing data obtained from multiple sensors for feature extraction is another open problem. More practical and effective data fusion mechanisms are required to combine the information obtained from multiple modality sensors. What kind of feature extraction should be used for accurate HAR is another research problem. That is, we should use handcrafted features or automatically learned deep features or hybrid features. So, in which situation, what kind of features we should use, which will reduce our complexity, time complexity, cost, as well as it will give a right decision in less amount of time. So that is one open issue to be investigated. For wireless sensing in HAR, RSSI and CSI based sensing need to generate training profile, which could be easily changed by surrounding changes. A huge additional effort has to be given to retraining the profiles, which results in a hike in labor cost and system downtime. Users' orientation and location influence the performance of HAR-BARI wireless signal-based sensing. Overcoming this limitation in RSSI and CSI-based sensing is an open research problem. Because where the person is located, depending on that, depending on that, the recognition performance depends. The safety and security of user health data, that is the very important thing, that is the security of health data. Because if the security of health data that is gone, then the data will be corrupted, and that will be a life threatening hazard to the, or life threatening problem to the people who are using the IoHT devices. Crowd HAR, most of the HAR systems predict a single user. Information gathered from social networks or from a target sample population could be effectively used to recognize activity levels of sedentariness, exercise habits, and health conditions. So that's all. So this is, I think, that portion of this huge topic I am able to cover in this lecture, and there are many more issues which could be addressed who is interested by interested researcher. And now you may ask me any question and I will try to answer. Thank you.
If there is any query, the participant can ask. Otherwise, we can share the email ID of ma'am, and you can ask the
Yes.
question later on over the email.
Yes, if you want some resource material, then also I can share.
Yes, ma'am. Okay, ma'am. We will share once we will receive your. We are having the email ID. We will
Yes,
share
yes.
with the participant. Okay, ma'am. Thank you for the very nice talk, and which is very informative, and which is also targeted to our concerned FDP topic. Thank you, ma'am. Thank you for
Okay.
giving such a nice talk.
Okay. Welcome, sir.
Thank you. Okay. Okay. Thank you.
Okay.
Participant will receive one feedback link for this talk, and which is also the attendance part over the WhatsApp group. Thank you all, and we will join back tomorrow with a new session. Thank you.
Okay.
Yeah.